All right, it's 1 o'clock, so time to get started. I'm excited to see you all here. I look forward to coming to SAINTCON every year. This is my fourth or fifth year coming probably. I started out as a volunteer working security, so I was one of the ones that stood and made sure you had your badge when you came through the lunch line a couple years ago. And I loved it, and so I have gotten more involved since every year. I've been doing Wireshark training now for the last 3 years, and it's always similar but always a little different. So I'm excited. If you haven't yet downloaded Wireshark, you'll want to download Wireshark and the capture files that we'll be using. So the links here are posted, and I'll leave it up for a second. I'm going to go back to a couple of slides, and then I'll come back to this one. So I can't remember if I already said my name. I don't think I did. I'm Kyle Fates. I work at Weber State as a professor in the School of Computing. I love it there. It's great. We're hiring. We're always hiring. So if you want to try out academic life, come talk to me. How many people still need time to download Wireshark or the capture files? Okay. So as you're downloading that, let me talk a little bit about what we will and won't be doing in this training. So what we won't be doing is any live capture. We will be using existing capture files to look at and analyze. And there's lots of fun and cool stuff we can do with that. Live capture is awesome because you can see exactly what's on your network, but you need to be aware of where you're doing live capture and if you have the permissions there to capture. So that's this bullet point here of know the law and company policy. Don't just start capturing traffic on your company network. They might get mad at you. Right? But if they've assigned you and said, hey, we need you to look at this, then yeah, absolutely, Wireshark can be a great tool for doing that. I'm going to assume that you have some knowledge of networking and networking protocols. I'll still try and touch on the basics so you're not completely lost if you don't have a little bit of knowledge on networking protocols. But you certainly, as we sort of go deeper into a protocol, you may start to get a little lost, and that's okay. I was in Troy's talk earlier this morning about imposter syndrome, right? And how a lot of us feel inadequate and like we don't belong and those around us have more knowledge. And I don't want you to feel like that in here. I'm not an expert, or maybe I am an expert, but I'm not any more expert than anyone else here. I've used Wireshark for a lot of years. I've taught Wireshark for a lot of years. So I know quite a bit about it, but that doesn't make me any more knowledgeable or capable. So keep that in mind. Use this as an opportunity to collaborate and talk and work with one another. That's one of the things I love about SAINTCON is it's such a great place to meet people and get new ideas and find out new ways to do things. Okay, so how are we doing on getting the capture files? Have those downloaded okay for everyone now? All right. So even though I said we're not going to be doing any live captures, I do want to talk about it for a minute so that when you go and try and do live capture and you're like, why am I not seeing the traffic that I'm expecting, you'll know why. So we'll start out talking a little bit about that. We'll talk about having a baseline, knowing what your network traffic looks like under normal circumstances. And that's going to be critical to being able to find out if something abnormal is happening. Right? If you've got something malicious going on, or if you're just trying to understand a certain application, you've installed some new software and you want to know what it's communicating on the network. If you don't know what your traffic looked like before that, then it's going to be a lot harder to figure out what's changed. So we want to have a baseline. We want to then talk about finding that needle, finding that piece of information you're looking for in the flood of data. We'll talk about some of the basic protocols and interesting things that Wireshark can help you find with those protocols. And we'll look specifically, if we have time, at some different network reconnaissance scans and how those show up on your network. Okay, so that's sort of where we'll be going and talking about today. Feel free to bounce in and out of here. It's a 2-hour session, so if there's a talk halfway through you want to go to, I won't be offended at all. I'm just happy to see you guys here. So if this is our hypothetical network where we've got a couple different LANs and a wireless LAN and a connection to the rest of the internet, and we want to capture traffic on this network, the thing we have to remember is that not every device sees all of the traffic. Back in the good old days when we had hubs everywhere, that was the case, right? A hub would send the traffic to everyone, and it was really easy to capture traffic. Well, now our devices are smarter. We have switches that only route traffic to the MAC address, right, where that traffic belongs. And so if I'm on this device N10, and I'm capturing traffic locally on this N10 device, it's really only going to see traffic meant for it. And it'll see, right, any traffic that it's sending as well. So it can still be powerful, but it's not going to be as powerful as if you had a view of your entire network. If it's a switch, if it's just a dumb switch, then you're going to have to insert a network tap into your line and to capture traffic that way. If it's a managed switch, then a lot of times they have features available to do port mirroring, where you can say, hey, everything that you're seeing on these ports, send out this one port, and that's where you would then capture. Okay. Similarly, with your wireless traffic, if you're capturing from a Windows device, you're not going to be able to see the rest of the wireless traffic. The drivers just don't support it. But you can get drivers, you can do capture wirelessly in what's called Promiscuous Mode and see all of the wireless traffic around you. I remember the first time I did that, I was in college, and my professor was teaching me about this kind of stuff, and I went home from college, right, to my parents' house, and back then they had an open wireless network, because that's what lots of people did. And so I fired it up, and sure enough, all of the traffic that my parents or my siblings or whatever were browsing wirelessly, it was right there, visible. And I was like, Dad, look, this is why you need to put a password on your network, because anyone driving by your house can see this. So it's kind of eye-opening what you can do with Wireshark. Okay, so let's talk about our baseline. What does normal traffic look like? There's all kinds of ways you could describe what normal traffic looks like. You could talk about what protocols are used and what percentage of your traffic is those protocols. So how much of your traffic is HTTP traffic, or how much of your traffic is SSH traffic. You could talk about what hosts are commonly communicating on your network, and hosts by IP address, hosts by MAC address. So we have all these different characteristics about our network, and it's going to be specific to our network. I can't take a baseline of my home network and use that to then understand what's going on at Weber State's network. Their characteristics are going to be very different. And it would be the same with any of your organizations or networks that you're working on. Every network is kind of unique in what kind of devices are on it, what kind of processes and protocols are being used. So I've set up a couple capture files, well, a whole bunch of capture files that you've downloaded. Let's go ahead and open one up and see, take our first look at Wireshark. So I've got Wireshark open. If you have the capture file, already downloaded, you can double click on it, and a lot of times the file association will open it up in Wireshark. But we just want to open the baseline PCAP capture file. And you'll have 3 different windows or splits of ways to look at your network traffic. So the first one is our packet list. And so here where we have all these numbers on the side and details, and your list might look a little different than mine. I'm going to switch my profile to default. We'll talk about using profiles in a second. Now your list should look a little pretty similar unless you've already made customizations. And so these are the packets that we were seeing at the time that I'd created this capture file. And so as we click on a different packet in the list, you'll notice the other 2 views down here change. And so the next view is our packet details, and it breaks it out by protocol, and it says, okay, at our different layers of our networking model, we have our Ethernet header, our IPv4 header, our TCP header, and we can break out and look at those individual pieces, and Wireshark interprets all of those fields for us. And then the third view is the raw data view, right, where we have the actual hexadecimal values on the left and the ASCII interpretation of those values on the right. And so all 3 of these views are useful in understanding our network traffic. But what we want to look at first, we're talking about baselining this traffic, is looking at some of the statistics. And so up here in the menu, under our statistics, we have all kinds of different statistics, and we'll go through a few of them. But right now, let's just start with the capture file properties. And the statistics I'm most interested in are the ones down here at the bottom. That's probably small. It's small for me. Is it small for you? So we'll use the magnifying glass sometimes when things get a little too small, so that hopefully you can still see them. All right, so under our statistics, we have statistics about the packets that have been captured and the packets that are displayed. Right now these statistics are the same because we're displaying all of our captured packets. We can see how long our capture lasted for. We can see the average packets per second, so that's our PPS. We can see average packet size. We can see number of bytes, average bytes per second. And so this gives us a feel for how much traffic is on our network. And it's the start of our baselining process. Right? So if we normally have 30,000 bytes per second flowing on our network, and all of a sudden we see a spike and we're at 100,000 bytes per second, that's 3 times more traffic than we normally see. And we might be going, well, what's going on? Why do we see that much traffic? Oh, my daughter started streaming Netflix or something, right? So we just want to be aware of the patterns of what's normal for our network. The other statistics I want to look at right now is the protocol hierarchy statistics. And so this covers not only what packets, how many packets per second and that kind of stuff, but specifically it breaks it down by protocol. And so you can say, how much of my traffic is IPv6, and in this capture, it's practically nothing. There were 2 packets out of the 300 or 30,000 packets that were IPv6. We can say how much of it was IPv4, how much of it was TCP, and so it gives us percentages, it gives us raw number of packets, and it also gives us some of those values in terms of packets per second, or in this case, bits per second. And again, this just helps you get a feel for your network and understanding what kind of traffic to expect when you're looking at a particular capture file. Okay, so let's go ahead, get rid of the magnifier for now. And I've got two different capture files here. I would recommend pulling them up side by side, open two different instances of Wireshark, and just compare statistics on them. Compare the capture file statistics, compare the double time capture file statistics, and the protocol hierarchy statistics. After you've looked at them for a minute or whatever, then I want you to turn to your neighbor and talk about what differences you see, and if you think those differences are significant, or if they're within what you would consider normal, and you would say, oh, this is still pretty much the same type of traffic and the same traffic patterns I'm seeing. Okay, so let's take a couple minutes, open these two up, look at the statistics, and then talk about them with a neighbor. And I'm going to wander around if you have any questions about looking at statistics. Okay, so a couple people have come in late, and so if you need the capture files, here's the link again. It's icarus.cs.weber.edu/tilde-kfates/download/SAINTCON-captures.zip. And I'll leave that up as we talk about what you found. So what do you guys think? Are these capture files mostly similar? Are they mostly different? What things did you find that were either similar or different? The total time that was captured? Yeah. So you don't want to be looking at just the raw numbers because one of them's like twice as long as the other one or something, right? Good observation. What else did you see with looking at these? Okay, yeah, so if you just look at the raw number of packets, right, that's not a fair comparison because they're capturing over different amounts of time. But then if you look at the per second statistics, those now average it out over time. And so what did you see? Are they similar throughput? Or are they different in terms of bytes per second, let's say? Double times higher. How much higher? Almost double. The name gives it away a little bit, right? So now the question is, would you call it a significant difference? Well, it depends on how much fluctuation you would normally see. So even having one capture file and saying, okay, this is my baseline, and having another capture file and saying, oh, this one's different, well, there's going to be differences as you capture. The question is it different from normal? And you can't know from just one capture file. You can't really even know from two capture files. You need to be consistently looking at your network and saying, okay, during this time of day, at this period, this is what traffic typically looks like, to be able to answer, are these really different from one another? So they are absolutely different in terms of raw numbers. The one that has close to twice as many packets flowing per second as the other, but it's not so high that you would say, oh yeah, there's definitely something has changed on my network, right? Because it could just be the flow of traffic that day or whatever, okay? So let me, in case anyone has not seen that, so we have our baseline, and we'll start another instance of Wireshark here. And open up the double time. That's not right, double time. No, that name still Steve 2017. Double time. And what are we doing? Capture file properties. Okay, so in my double time capture file properties, I'm seeing on average 62 packets per second and an average packet size of 868 bytes. In my baseline capture file properties, I'm at 52 packets per second and an average packet size of 58 or 588 bytes. And then average bytes 30,000 per second, whereas double time was 53,000 bytes per second. So we have two kind of differences there. One is the number of packets per second, and that's not that different, right? The one's 52 packets per second, the other is 62 packets per second. But these packets, not only are there more of them, but they're also larger, so that our total bytes per second ends up being, close to twice as many, 30,000 bytes per second versus 53,000 bytes per second. Okay? Does everyone know where I'm getting those numbers? We good? All right. One more time, if you need the link, take a picture because I'm moving on. So, we've talked about baselining, capturing some basic traffic, getting an understanding of our network. Now we're ready to start finding interesting things, right? Finding what's actually happening on our networks. And Wireshark has a lot of good tools to help with that. And so they have tools to limit what you capture. They have tools to limit what you see when you're looking at a capture file. And they have tools to highlight what you're looking at. And so those are our capture filters, our display filters, and our coloring rules. As we use those, we'll have different needs at different times. So sometimes we'll be trying to understand what's going on with our HTTP traffic. And so we'll want a specific set of coloring rules and capture filters and display filters for working with our HTTP protocol. But other times we'll be trying to figure out if we're being scanned, right? If someone's doing an Nmap scan on our network or something. And so we need to look at different pieces of information. And rather than trying to look at different pieces of information all at the same time, we can create profiles that are custom built for what we are currently interested in. And so let's take a look at how to do that. So I'll turn on the magnifying glass again so you can hopefully see. Down here in the bottom right corner is your currently active profile. And if you haven't changed anything, it probably says default. If you just click down there, there will be a couple other profiles built into Wireshark. Not as many as you see on my list right now, because I've already created a bunch of profiles. And you can select any of those profiles, and it changes how things are displayed. It changes what rules you have active. But if instead you right-click down there, then you get the option to create new profiles and manage your existing profiles. So I'm going to go to my Manage Profiles. And again, now we have the list of profiles. And down in the left on that box, you have options to create a profile, delete a profile, or copy a profile. And that's what I like to do, is I like to copy so that I'm working from a consistent base. So I'll usually copy my default profile, which is what I'll do right now. And so we just click the little copy button, and then you can name it whatever you want. In this case, I'm going to name it my SAINTCON demo profile. And what profiles lets you do is it lets you make changes to Wireshark without it having to always be active. And so that I can, right now with my SAINTCON demo profile, now any changes that I make, if I completely screw things up or add a whole bunch of columns that I don't really care about, I don't care, because it's in this demo profile that I can just delete at the end or never use again, or use it all the time because I found out it's really awesome. So once you got it created, go ahead and select OK. And because we copied the default profile, nothing will change. We were on the default profile before, now we're on a copy of the default profile, everything should still be the same. So let's make some changes. One of the things you can do with a profile is you can change which columns are displayed in your packet list. And so currently, it's showing me the time relative to the start of the capture file. It's showing me the source IP address of the packet, the destination IP address of the packet, which protocol, which application layer protocol is being used, if applicable, the length of the packet, and some information. We can add any column we want, any field that is available in our protocol, we can have it display as a column. So maybe, let's just click on one of these. So I'm on packet number 1. If I go to my IP protocol in my packet details, I can see all of the fields that the IP header has. And I can add any one of those fields as a column. So for example, I can take this time to live field. I can right click on it and I can apply as column. And when I do that, it adds a new column up here to my display list. This is incredibly useful when you're trying to find that needle. When you are working with pick your favorite problem and you need to look at a specific value in your packets, you can just add it as a column and then scroll through and very easily see the value for every single packet in your capture file. You can sort on these columns. So I can say, which packets have the highest time to live? And sort it the other way so it's showing me highest to smallest. And now I've got a list of packets sorted by their time to live field. Okay, so that's one of the things we can do in terms of finding the needle. We can add columns to make the information more easily visible. Another thing we can do is we can create what are called display filters. Display filters limit which packets are shown in your packet list. So if, for example, let's take a look at our protocol hierarchy again. We have all kinds of different protocols being used. Right? We have some IPv6, very few. We have some IPv4, a whole bunch. We have SSH. 4% of our packets are SSH. We have HTTP, 22% of those are HTTP. Well, what if we only wanted to look at a specific protocol? We could create a filter to do that. So what protocol do you want to look at? SSH, okay? So I'm going to come over here to my display filter, and I'm going to type SSH. Most protocols can be filtered by their name in Wireshark. There's probably a few exceptions to that, but most of them, if you type in the protocol name as an abbreviation, that will be a valid filter in Wireshark to then show you only that type of traffic. And so once I do that, if we look through this list, you'll now see every single packet here is using the SSH protocol. Now this is a security conference, so I better warn you, don't trust this filter to be showing you all of your SSH traffic. Because Wireshark's not that smart. I mean, it's a really smart and powerful tool, but it's not going to be able to find traffic that it doesn't know is SSH. Right? So how does it know it's SSH? It knows by the port number. It says, oh, SSH usually uses port 22. So if it's using port 22, I'm going to call that SSH traffic. I think it has a couple others. We can check the properties here. So on our SSH protocol, in our protocol preferences, we can see which TCP ports it considers to be SSH traffic. And if you click on that, it gives you the list here. And currently it's saying port 22 and port 2000 or 29,418. If it's using those ports, it'll try and decode it as SSH. So if someone's being sneaky and running SSH on any other port besides 22 or 29,418, this SSH filter won't catch it. Right? So that's my warning there is you can't trust the filter in terms of saying, oh yeah, it's got all of my SSH traffic. Well, it's got all of your SSH traffic using those ports. This gets back to doing a baseline and knowing if you're running SSH on the standard port or if you're using a different port, and then configuring Wireshark appropriately. So if you run Wireshark, or if you run SSH on port 2222, you can add it to the list. And in this case, it probably doesn't make any difference because I don't have any SSH traffic on port 2222. But if we did, it would then get those packets as well. So that's nice. I can create this display filter. But what we want is to make it as easy as possible to analyze our traffic. And if every time I have to remember which display filters to type in, that's going to be problematic. So instead, Wireshark has these bookmarks of display filters. And you can save any filter that you type in to a bookmark, and it saves it to the active profile. So as you switch profiles, you can change which display filters you have saved that then you have quick access to. Again, because we copied our default profile, we have some filters already here created. I think, let me, whoops. Oh, it's because my magnifier was still on. Oh, come on. Where's our, here we go. So here's some questions for you to try and answer. And as you answer these, think about using display filters to narrow down what traffic you're looking at, and then save those display filters to your bookmark. And similarly, if you need to add any columns to your packet list, right, add those, and let's look at the baseline capture file and take 5 minutes or so and figure out which host by IP address is acting as an SSH server. What are all of the UDP protocols that are used? And then which IP address is associated with a MAC address? And in this case, I haven't given a specific MAC address. Instead, we'll look at several. Right? So just make a list of, oh, this IP address is associated with this MAC address. Okay? And if any of these questions you're like, oh, I don't even know what that's asking, as I walk around, ask for clarification, and if we need to, we can clarify with everyone too. Okay? Okay, so let's take a look and see what we found. I'm going to leave it like this first, and then I can demo as we need. So for the first question, which host is an SSH server? So by IP address, what did you find? I'm hearing lots, but I can't pick out what you're saying. 3.1. Okay, who said that? There you go. How did you find that out? Okay, so let me pull up here and see if we can sort of replicate your process. So, and I'll turn the magnifier back on. So the first thing is to just look at our SSH traffic, right? Yep. No, that's a perfect approach, is to match up, right, that info column, and then look over at your IP addresses and match them up that way. Yeah, that's a perfectly valid approach. Okay, so we're filtering by SSH so that we sort of start to drill down and just look at the traffic that we care about. As we do that, here's where there's like probably 100 different ways you could solve this problem. So one way was saying you can look over here in the info column, and it tells you which packets are server packets and which packets are client packets. And so you can scroll through that, and you can see all these packets that are server packets. And you can look over at the source IP address, right? Who sent that server packet? And it's the 3.1 address. Now, one of the things that I love about Wireshark is with its display filters, there's thousands upon thousands of possible filters, things that you can filter on. And so I don't remember all of the exact syntax of how to filter on any specific column or value, but I don't have to remember, because Wireshark makes it really easy. If I want to filter and say, show me the packets where the 3.1 address is the source, that one is actually pretty common, so I do just remember that, and I can type it in and say, so I want SSH, and I want IP.source, SRC, double equal sign for a comparison, and then the address, 192.168.3.1. And what this does is it lets me sort of double check my process and say, okay, anytime 3.1's sending packets, if I look over here in the info, it's always sending server packets. Okay? But if I didn't know that, or if I didn't remember that, I can also, so I'm going to go back to just SSH as my filter, I can find any field in my detail list, and I can right click on it, so I can find my source IP field, I can right click on it, and I can choose to apply that as a filter. And so I don't have to know what the syntax for the filter is. if I can find an example of it in my detail list. Because then I can just right-click on it and say, hey, I want to find values that look like this. Right? So I want to find ones where it has this IP address selected, or where it's not this IP address selected. And we can combine it with what we have already. We can say, take what I have and add to it, and this has to be selected, or this has to be selected. Okay, whoops, and I chose the wrong one. I chose selected. That got rid of my SSH. But you can see, right, then it builds that filter for you, and you don't have to type it in, and you don't have to know the exact syntax for filtering on all of the thousands of possible fields that you can filter on. Okay? Are we good on that question? Ready to go to the next? So our next question was, what UDP protocols are used in this capture file? What'd you guys find? DNS? DHCP? MDNS? Anything else? Okay, how did you guys find those? Okay. Perfect. So you can apply a filter for only UDP traffic. You can go into the protocol hierarchy statistics, which we saw previously, and you'll notice down here at the bottom, it tells you that you have an active display filter. And these protocol statistics are based on that display filter. So now, that should be 100% if it's UDP. Oh, yeah. It is 100%, but 2 of our 0.2% is UDP on IPv6. So we can see a list of all the protocols being used, and it's the exact 3 that you guys mentioned, DNS, DHCP, and MDNS. Okay? Some of the other statistics, let's look at some of those, because I said we would. This is as good a time as any. So you have these conversation and endpoint statistics. They let you look at endpoints, looks at either MAC address endpoints or IP address endpoints or port number endpoints. And conversations is very similar, but it looks at pairs. So it says not just the endpoint, but the 2 endpoints together, right? You have that conversation back and forth. There's always a source and destination. They're both endpoints, and when you put them together, then they become a conversation. So both of these statistics, instead of showing always what's displayed or always all of the packets, it has an option. By default, it's going to show you, what am I on, conversations? It's going to show you the conversations in your entire capture file, even if they're not displayed. So even if you've applied a filter, it's still showing you all of the conversations here. But it has this checkbox option to say, actually, only show me the display filter conversations. And you'll notice when I did that, I'm currently on the TCP tab of my conversations, and there's no longer any conversations listed because I've filtered to UDP traffic. On my UDP tab, I still have all of those UDP conversations. So that's pretty common. Most of the different statistics windows will either filter by your display filter or have the option to filter by your display filter. Okay, the final question, which IP address is associated with a given MAC address? So let me pull out a MAC address here. So if I have MAC address 0800279CEA71. That's my MAC address. I want to know what IP address is associated with that MAC address. What do you find? Or how do I find that? What's that? I heard it from this side of the room. Speak up. Now it's over here. Apply as filter. Okay, yeah. So if I filter on this MAC address that I'm looking for, so now my source address, right, MAC address, 0800279CEA71, right, that's the source. If I look at the source IP address, I actually see several IP addresses that show up with that source MAC address. Now that's okay, as long as I have an understanding of my network protocols. And this is where, like I said, you don't have to have a great understanding for a lot of this, but to start going into some of the details, we need to understand our protocols. So IP address, MAC address, they serve different roles. The role of your IP address is to identify the device on your entire network. Right? And so we have the IP address. If it's a public IP address, it's valid anywhere. No matter where you are, that IP address identifies your device. And whether you're talking to it here at SAINTCON, or you're talking to it in China, or you're talking to it at Weber, that public IP address identifies the location of your device. The MAC address is different. The MAC address is only valid on your local link network. Right? It's a layer 2 protocol, and so it identifies the device for your link local network. What that means is that in this particular case, this MAC address serves as the next step along the way for a whole bunch of IP addresses. Right? This is the MAC address of the router in our capture scenario. And so anything that's going to that to the router itself or out to the internet is going to use the MAC address of the router to get it to that one step. Right? And then the router says, okay, what's the IP address? Where's the next step along the way? Right? It routes the packet. So this MAC address, right, will show up with a whole bunch of different IP addresses. Let's try the other one. Right? So our 8027372C06 address. And so right now we're using destination when it's a destination. And if we look at the destination IP address here, it's always the same. Right? It's always the 112 address. Okay, and so we can see, oh, our 112 address is associated with this MAC address. All right, that's one way to answer this question. What other ways did people attempt to answer this question? Okay, look at the IP packet and do what? Okay, so let's make it really easy to do that. We already have our IP address as a column. Let's add our MAC address as a column. Right? So we can do that side-by-side comparison. So I'm going to, under my Ethernet details, instead of applying this as a filter, I'm going to apply it as a column. And then I'm going to put it right over here next to my destination IP address. And clear out my filter so we can see different ones. And now we can answer that question for any pair that shows up as a destination. Right? We can see when it's a destination, right, the 113 address uses the 71 MAC address. The 112 address uses the 06 MAC address. The 34 address uses the A8 MAC address. Okay, and so by adding that column, it makes it a lot easier to visualize that information. Okay? Did anyone try and use the ARP protocol? All right. Were you successful? Okay. Tell us what you did. Perfect. So if you couldn't hear, he's saying he applied an ARP filter, right? ARP. ARP is our address resolution protocol, which, again, if you have an understanding of network protocols, it makes doing this analysis in Wireshark a lot easier because you can start putting these pieces together and you can say, okay, I need to associate a MAC address with an IP address. What can I use to do that? Oh yeah, ARP, the address resolution protocol, that's what it does. So we take a look here, and essentially the way it works is it sends out a request and it says, hey, I'm looking for this IP address. What's the MAC address associated with it? Right? And so we get all of these requests that look like that. Who has this IP address? Who has that IP address? Who has this IP address? And then we also get back responses. Right? It says, oh, that IP address has this MAC address. Or, so that's, this address has this MAC address. And it's a great way to look at IP address and MAC address associations. In terms of, if we're just looking in general, we can apply our ARP filter. If we're looking for a specific MAC address or a specific IP address, then we can use our filter to get more specific. I think the question I asked was about a MAC address. I said, this particular MAC address, what's the IP address associated with it? So we can just do a filter for let's get a response packet. So I'm on packet number 936, which is a response to an ARP request. And using that, I can say the 3.1 address is associated with the EA71 MAC address. But what I'm really interested in is how do I build a filter? So I'm going to select that, right-click on it, apply as filter, and then I get the syntax. I say, okay, if I want a filter for an ARP request that has the source hardware MAC address as this, right, that's my filter. But that's not exactly what I want, because that will include both requests and replies from that address. Right? So you'll notice in our filter, sometimes that address shows up as the one responding, and sometimes it shows up as the one asking the question. And we're really only interested in when it responds with the answer. So we can add to our filter, and we can say the ARP protocol has a field that says whether this is a request or a reply. We say, okay, I want to find the cases where it is, whoops, I wanted to do that with an and. So I've got it as a reply, and a particular address. Now I can very quickly answer that question of which MAC address is associated with a given IP address, or vice versa, which IP address, which is I think how the question was worded, is associated with a particular MAC address, because I've got a filter to do that. And I can save this filter, and even though it's got a specific MAC address in there, it's now very easy for me to change the question and say, oh, but actually I don't care about that MAC address, I care about some other MAC address. Right? I care about the, as an example, 080275551DA8 address. And then I've got the answer. Oh, that one's the 3.34 IP address. Hey, this one seemed useful. I'm going to save this as a filter. And I'll call this my MAC IP lookup filter, or something like that. Okay? Questions on any of that? All right. Turn off the magnifier. Based on time, I'm going to just talk about this briefly. So we've looked at display filters. We've looked at adding columns. Another way that you can customize the information that you see in Wireshark is with what are called coloring rules. Coloring rules have the exact same syntax as display filters. So anything that you can do with the display filter, you can do with a coloring rule. And the difference is a display filter limits what you see. Right? It shows you only the information that you've filtered on. A coloring rule leaves all of the data still visible, but it will highlight or color the packets that the rule matches. And so it's a way of getting context around your packets, but still being able to focus in on the information that you're interested in. You'll notice, let me clear out my filter, Wireshark already uses coloring rules. And you might have been wondering, why are these different colors? It's because of the coloring rules. So in the packet list, to help you process all this information, Wireshark colors different packets differently. So some of them are green, and some of them are blue, and some of them are black. Some of them, where's the brownish ones we just saw? Well, filter to ARP and we'll see them again. And some of them are the tannish brown. Okay? Wireshark has built-in coloring rules, and you can create your own. You can say, what I really care about is making sure that I notice all of the SSH traffic. And so instead of having it be this sort of bluish color that doesn't stand out, you can create a coloring rule that makes it bright pink. And the way you do it is under your View menu. We better do the magnifying glass. So under the View menu, there's a coloring rules option. When you select that, it lists all of your coloring rules that are active. And it has, similar to our display or our profile options, the ability to create new ones, delete existing ones, copy existing ones. And the trick here, there's two tricks. One, it goes from top to bottom, so as soon as a rule matches, it applies that coloring and then stops. So if you have HTTP here being colored green, and later on you have TCP being colored purple, HTTP is using the TCP protocol. So it could be colored either color. It could be green because it's HTTP, or it could be purple because it's TCP. Well, it'll be colored green because HTTP coloring rule is listed first. So that's something to keep in mind when creating these coloring rules, is if multiple rules match, it's going to color based on the earliest rule in the list. So I said we were going to do one for SSH and make it pink. So I click the plus button, I enter my display filter, and again, it's the exact same syntax as our display filter. You can, create a display filter first, make sure it's filtering the packets that you want, and then add it as a coloring rule. Give it a name like SSH. And then the way that you set the colors is down here at the bottom. There's two buttons to set the background and the foreground. And this is the one, not the one thing, but one complaint I have about Wireshark's interface is the color of the button is the color that it's describing. Even though, so like foreground is the foreground of the text, right? The text coloring, it's the background of the button that the color is, right? So the foreground currently for this coloring rule is black, and the background is white. And I'm going to change that. Let's make the background some nice pinkish color. And we'll leave the text black because that's mostly readable. The other step or trick I'll tell you is make sure you check the little box. I don't know how many times I've created a coloring rule and it doesn't check the box by default, and I go ahead and hit OK and nothing changes. And I'm like, what? Is my syntax wrong? And I go in and check it 10 times, and then I realize, oh, I forgot to check the box. Right, so if the box is not checked, that coloring rule is not active. Okay, so as soon as we hit OK, all of our SSH packets turn this nice bright pink, so that when we clear our filter and are scrolling through, now we can see the context around those packets, we can see what else was going on, but they still stand out to us. And we still say, this is what I'm really focusing on, and I just want the context around that. Way over here on the right, there's this tiny little sidebar that is a representation of your entire packet list squished, right? So that you can use that to jump to a specific spot in your capture file and say, oh, here's a lot of pink. Let me get up there, and you can click on it, and it takes you to that spot in the packet list. Okay? Turn the magnifier off. I'm going to skip the demo unless you guys want some practice doing coloring rules. Are we okay moving on? All right. So let's talk about some protocols and some of the things that you might be interested in doing with those protocols, some of the values you might be interested in filtering on. We talked about ARP already as we were doing that. We've seen IP address filtering, where you can filter by a source or destination. That's probably the most common field you'll use when you're filtering at the IP protocol. ICMP we'll talk about in just a second when we do our network reconnaissance, so I'm going to save that one. UDP and TCP, again, we've talked about a little bit as we've been doing our baseline analysis. One of the things with UDP is that it's a very simple protocol, so there's not a lot that can go wrong with it, which is nice from a troubleshooting perspective. Usually, either it works or it doesn't work, and if it doesn't work, depending on which side of the capture file you're on, you just don't get the packets, or you get the packets and you don't get a response, and UDP has no mechanism to recover from those errors. I want to focus on these last two, though, HTTP and FTP, because Wireshark provides some really neat ways of interacting with these two protocols. So in this baseline traffic, you can filter to HTTP traffic and get a list of all of the HTTP packets being used here, and you can see what requests were being made. You can see the responses as you go through. You can do things like, let me get to a different request. Here we go. So, here was a request made to a particular server, and it's just a request for the root of that URL. One of the things that you can do is you can do what's called following the stream. So right now it's intermixed with all of the other packets, except that we've filtered it to HTTP. We can then follow either the TCP stream or the HTTP stream, and they're going to be very similar in how they work. Let's start with the TCP stream. And this gives you the actual ASCII text of that exchange. Right? And so you see the GET request. It was to google.com. You see the headers associated with the request, and then you see the response. And you see the headers with the response, and you see the actual response itself. One of the things you'll notice, right, in this case, the content encoding type is gzip. So it's been compressed, which is why when we get down here, the response doesn't make any sense, because it's all compressed data. Lots of times, with lots of protocols, like if you're doing FTP or even HTTP when they're not doing compression, the plain text will be right here following the stream. And you can see the entire request, you can see all the data, and you can save it. Right? So there's options to save this stream out to a file. With HTTP, they make it even easier because they have this export objects option. It says you can export objects as HTTP. You can find all the HTTP objects in the file, and it'll list them. And it'll say, this web page, this image, this media file. Here it is. Right? Every response HTTP object that was sent back is in this list. And you can filter text, and you can find a specific piece of information. Let's find one that's somewhat interesting, maybe. do by content type. This is slightly boring because there's no images in it. Yeah, okay. But we'll demo some text then. So I can do, right, here is our request to Google, right, the root URL, and I'm going to save that. And let's save it just to the desktop for now. Google.html. And if I can get my PowerPoint to go away. So now on my desktop, I've got this Google HTML file, and it is the web page that was downloaded from that capture traffic. And it's taken care of, right, because now it's in my web browser, it's taken care of the gzip compression, and I can see the actual, right, data. The other thing I can do, if I don't want to save it to a file, if I choose to follow the HTTP stream on that, so I did a TCP stream last time. If I do a HTTP stream, Wireshark's pretty smart, and it says, hey, I can understand HTTP headers, and I can look at the content encoding, and if it's something that I know how to decode, it'll decode it. So if it's compressed data, you can still get the plain text right here in Wireshark. You don't have to save it out as a file. You can, because oftentimes maybe that's what you want, but if you don't want to save it out as a file, you just want to see the plain text of it, you can follow that stream and see the entire request and response all in plain text. Okay? Questions on that? All right. So let's look at, we've looked at some basic protocols and things you can do with them. Let's look at now from a security perspective and say, how can I use Wireshark to see if someone's scanning my network? Or, that's what we're going to focus on. You can go a lot further. You can say, how can I use Wireshark to see what my network traffic looks like when I'm infected with, the WannaCry or wannabe virus, right? Or what does it look like when a heartbleed attack is going on from the network perspective? And Wireshark gives you all of that. But let's just start with a simple network reconnaissance. What does it look like when someone's doing a port scan or doing a host scan or is trying to detect what operating system I'm running by sending a whole bunch of network requests? So I told you we'd talk about ICMP. It'll show up here. If I want to know what hosts are on a network, there's lots of ways I could do it, depending on where I am in that network. I could use DNS and say, I could do DNS reverse lookups and say, hey, here's this IP address. Is there a DNS entry here? Now, from an attacker's perspective, that could be nice because that could happen outside of your target network. Right? And your target network won't see that you hit the DNS server because the DNS server isn't even part of their network monitoring. So you may or may not see those requests depending on where you're capturing and where they're happening. We saw ARP as a way of determining IP addresses. Well, you can use that to determine devices that are active on the network. From an attacker's perspective, ARP's particularly powerful because you cannot disable it. Right? ARP is required for your networks to work. But the downside of it is it only works in your local link network. Right? It doesn't traverse a router. So you have to already be inside the network to do an ARP scan. ICMP is sort of in between those two. It's going to give you a view of what's on the network, but it's also going to be visible to target network administrators, and it can be disabled. They can block it at the firewall, and nothing major is going to break if you're not responding to ICMP requests. ICMP is the protocol that Ping uses. Ping uses it, Traceroute uses it by default, so if you've used those utilities before, that's our ICMP protocol. So I have a bunch of capture files in the folder that have this as their starting name. Right? So nmap underscore S capital L, nmap underscore SN, nmap underscore external. These are different captures of a nmap scan as it's happening on the network. And the reason I do asterisks here is because there's two different versions. Right? There's one version that just shows the scanning traffic, and there's one version that shows the scanning traffic intermixed with the baseline. So the version that has baseline included in it includes baseline traffic. The file name without baseline doesn't include baseline traffic. And the goal here is to create coloring rules and filters that let you spot the nmap traffic. Right? So open the traffic that's just nmap, look through it, see what characteristics or what things you could create a display filter on to show you only those, what coloring rules you might use, save them to your profile, and then load the baseline capture file and see if it helps you identify that scan is occurring. Okay, so take a look at these 3 capture files, really 6 capture files, and then we'll talk about rules that you use to help highlight this scanning process. So how are we doing? Do we need more time to look at these? Do you want to look at them together up front? Are we in the afternoon stupor and are no longer capable of communication? Yeah. Should we look at it up front then? Okay. All right. Where are we on time? We probably won't go through all of these, but let's pick one of them. Which one do you want to look at? SL, very first one. All right. That's probably the one most people have at least looked at. So we're going Nmap SL. So what's the first thing you notice about this capture file? Lots of DNS queries. Okay? So there's Nmap SL, and by the way, the name of these is based off the flags that you use, that you pass to Nmap to accomplish this type of scan. So this is a DNS scan, right? That's why there's all these DNS requests, is because it's attempting to enumerate host names for all of these IP addresses. So what else do you notice? Lots of DNS requests. What do you notice about them? All coming from one source. What else? And sequential. Right? It's just brute force trying one IP address after the next. And it's trying it using this reverse lookup. Right? So DNS usually goes from a domain name to an IP address, but it can be used in reverse to go from an IP address to a domain name. Now, I would suggest, in terms of filters and coloring rules, that in itself is probably a good coloring rule to have, to highlight anytime you see a reverse DNS request. Because they're not very common in everyday browsing. Right? In fact, if you go back to the baseline, not the Nmap baseline, just the normal baseline, and try and find a DNS reverse packet, there's probably not one there. We could pull it up and check. So we need to create a filter for reverse lookups, or that's one approach. Did anyone try and do that? Yeah? What did you use for your, were you successful, and what did you use for your filter? Okay. So let's use our newfound skills and say, all right, if I can find a field that looks like what I want, I can filter on it. Okay, so we want the request, right, because that indicates a scan. So one thing we might do is filter for this. So apply as filter. Oh, got to get it lower in my window. There we go. So that'll get us partway down the right track now. This will only be highlighting DNS requests. How do I make it so that it highlights DNS requests that are reverse lookups? If we expand out the query, we see this type. And again, here's where some understanding of the DNS protocol might be helpful. And if you have less understanding of it, looking at the baseline file and looking what a normal DNS request looks like and comparing it to this allows you to see the same thing. So a normal DNS request, the type will be A for IPv4 request, and it'll be 4 A's for IPv6 request. The type for a reverse lookup is this pointer type, which makes a great way to filter. So I'm going to say it's not a response, and it's a pointer type, right, which has value of 12 in terms of its decimal value, and apply that as my display filter. Once I sort of scan through this and say, yeah, that's filtering to all of these reverse lookups, that seems to be what I want, I can grab that and move it to a coloring rule. And we'll just do a new one. Put in the rule we just created. Call this our DNS reverse lookup. And make it something that'll stand out. So I'll go with like a red for a nice warning color. Black doesn't show up so well on that red, so we'll change the foreground to white. And check the box. Yep. Okay, so all these show up now in this nice, easy to see red. Let's see how it works when we load it in our baseline file. So we open nmap sl baseline. Clear my display filter. And what this does is it lets me, as I look through my baseline file, I'm going, yeah, everything looks good, looks good, looks good. Oh, wait a minute. Why am I seeing all these reds? What's going on? And it just alerts me to look at this in a little more detail. Say, okay, oh, I'm getting a whole bunch of these in sequential order. It looks like someone's doing a DNS reverse lookup. As someone over here, I think, pointed out, we can then use Wireshark to start doing some next steps. Right? We can say, not only am I under attack, is someone actively scanning my network, but I can see where that scan is coming from. It's coming from the 232 IP address. So I now know, oh, let's use what we just learned about in terms of looking up that MAC address. Maybe we already have it in our management system, but if we don't, we can use Wireshark, look up the MAC address, and go to our inventory and say, okay, which device is currently, right, has this IP address? Well, which MAC address is that? Go, physically check it out. Is it, oh, that's my partner right next door. He must be, doing a security audit. Or, oh no, that's the guy downstairs. I wonder if his computer got infected by a worm. Let's go check it out. Right? It gives us a place to start looking for more information. Okay, we're about out of time. Is there anything you want to know about Wireshark, questions you have that we didn't get to? Okay, if not, like I said, I've been using Wireshark for a lot of years, and I still don't know everything you can do with it. I hope this has given you a place to start and to start using Wireshark. Find ways to use it. I've had several people, I teach a class at Weber using Wireshark. I've had several students afterwards come up and tell me, I started using the Wireshark in my job and I solved this problem no one else could solve, or I figured out why our network connection was slow, or it's a very powerful tool, and so I encourage you to keep exploring and using it. And I'm happy throughout the con, if you run into any questions about it, I'll be here through Friday, and I'm happy to talk to you and meet any of you, and I hope you enjoy the rest of the con. So thank you.